So this is my NMI Interrupt Lab, and I have my Allen 1 computer, Allen 1 CPU connected to my computer, and then my VIA connected to my LCD screen, and then over here I have a pull-up resistor connected to a button. So I don't know if you can see, but when I click so this is connected to the NMI, which is actually initialized when it's low. So when this button is pressed, it basically connects it to ground. And you can see that there is a light going off for that. So you can see it's de-initialized, or it is initialized because I'm turning it to ground. So we know the button works, but so basically the goal of this lab is to have you're gonna display 4 zeros, then every time you press the button, so when it detects that you do, it's gonna increment it by 1. So you'll see that the last digit is just gonna keep incrementing up. So I can show you the code that I did for that. So I used the skeleton that Mr. McEwen gave us. And I used a lot of the same code I had for converting from hex to ASCII, and then also like displaying hello world. I used a lot of the code for that. So this is the things we did in class. I have a counter, so it can like increment properly. And then this is like the general reset we went over, and that's just gonna set the stack pointer to high. And then this is just gonna like add things. I have a low byte, which is the second 2 digits, and then the high byte, which is the top 2. And it's basically just adding 1. It's gonna like store the value, then it's just gonna add 1 every time, and it's gonna get the value again, and then just gonna keep adding 1 to that. And then this stuff to hex to ASCII, I had it before. 4 of these just means it's gonna rotate the bit left 4 times, so it gets converted and saved into a different address. And then there's like a carry bit. So these are LCD data. That's basically how like this is a initialization, like the cursor and like clearing everything, and then this is the data. You can see this goes from 040 and this one does 050 because this is like a synchronous device, and this is how it runs. Then NMI, for NMI I'm using like a carry bit, and I wrote some small comments so you could tell. And then this is for my IRQ, which I am not using yet, but that will be for next time. Right now we're just using the non-maskable interrupt. And I can basically show you how this code works in action. So I can save my ASM file, then I can go to warp, and I can assemble the file using this command, and then inside Allen 1 I can do faa.out, which will basically flash it to the Allen 1. And then so I have my clock speed really fast, so it's not going to show anything on the side, and my program will work almost instantaneously. So I can just restart, TT, and then once I toggle the auto clock, nothing's going to show up here, but we can pay attention. You can see that it is running very quickly, and it did print out 4 zeros, and you can see that the running stopped in the VIA. But now I'm going to click the button here and watch. So it's going to go through all the bytes again, and it's going to add 1 to the very last. And you can see it was running before, but now it's stopped. And then every time I press the button, it will just increment higher. I'm going to press it one more time. So yep, it's basically just adding 1, then like redisplaying all of them and editing as it goes. So yeah, I'm just going to turn off my clock. And yep, that is the lab for the NMI. I'll be back for the IRQB.